Hello, hello, hello. Um, Welcome. Doing another math homework help video here. You're gonna have to excuse my voice on this one. I've been I've been getting sick, so it sounds a little sicky. I don't know how else to describe it. Yeah. So if I clear my throat, pardon me. And if you can't understand me as good, I am so sorry. I'm doing as good as I can, I guess. Okay, so we're going to do 7.7, writing exponential functions. And I have Desmos open here because I'm going to be using that to evaluate. It's just for a calculation. I really don't need graphs or anything. So let's get this thing started. This video I actually remembered to change the size of my face so it's not covering up the answer box. Hooray! Alright, at the time of recording this video, have not explained to the students how to do 1 and 2. However, I guess by tomorrow, the day after I post this, I think, we will have done this. So I'm just going to explain how to do it here. Now, the process by hand is very tricky because what's happening is you're going to need to figure out, let me write this on here. You're going to write y equals a b to the x to show you visually. You're trying to write an equation like that, but you're supposed to put values for a and b, the perfect values that make these outputs true when you plug in -1, 0, 1, and 2, right? And the way you do that is you're supposed, the normal way is if you're given at least 2 points and you're told it's an exponential function, you can go through all this trouble by plugging in x and y and going backwards and solving a and b and all that stuff. But for these problems, I'm going to kind of just show you the easy way how to do it. So if you're watching this, you're getting the easy way, okay? The a value is essentially the y-intercept. For example, if I were to make, hold on one second, let me make b something interesting. Okay, if I were to make a 1, the y-intercept is 1. If I change a to 4, the y-intercept is 4. If I change a to -6.5, the y-intercept is -6.5. Whatever a is going to be the y-intercept, at least in these generic formulas, with no additional stuff. If it's just a b to the x, the y-intercept is whatever a is. Like, that can change if you were to add, like, if I minus 2 at the end, well, now it's -8.5. Like, it's 2 less than whatever a is. So things can get tricky, right? But for these, they're not asking us to do that. They're just asking you for a generic a times b to the x style function. So here's why I mentioned in all this y-intercept stuff, because if you know what the y-intercept is, you already know what a is. So in this equation, you'll notice one of the points, or equation, this table, one of the points given is 0, 8. That's the y-intercept. 0, anything is a y-intercept. So they've given you the y-intercept. So I automatically should say a is 8. So I'm going to do that on here. You don't have to do this graphing stuff. I'm just showing you here. I'll go faster on the next one. Okay, so check it out. The y-intercept is 0, 8. Okay, it follows that rule, right? But does the rest of this work? Like, if I go and I try and find 1, 32. If I go over 1, is it up 32? Not so much. It's actually up 16. Darn, not enough, right? So here's what b is. B is how much is the y value multiplying by as it changes. So if I look at my y column, I should say to myself 2 turns into 8, turns into 32, turns into 128 as it multiplies by 4. So if the b value is made to be 4, oh geez, come on, slider. There we go. It should follow the rules now. 0, 8 is still 0, 8. 1, 32 now exists as I want it to, and I could even check the other stuff, but I'm telling you right now it's going to be true. I could show you -1, 2 is on the thing, because it follows the following two rules. The a value is the y-intercept, which is 0, 8, so I put 8, and the y pattern is multiplying by 4. So when I put it all together, I write y equals 8 times 4 to the x. Now, I don't think you have to write these exponents. These parentheses. I'm going to do it. See if it gets mad. Yeah, see, it says your answer is correct. However, parentheses don't have to be used, and it suggests that I do 8 times 4 to the x instead. If you want to skip on the parentheses, you'll be fine. I'd write them. It doesn't seem like Alex is going to mark you wrong for doing it. And not to mention, what's really weird is that Alex has problems that they put the stuff in parentheses. Like, why would they say don't use parentheses when they themselves use parentheses on some problems? Whatever. All right, let me do this next one super quick. Y equals, and then the A value is the y-intercept. I can see 0, 6 is on the table. And then what's happening to the y? It's going 2, 6, 18, 54. That's times 3. So 6 times 3 to the x. I put parentheses. Alex isn't going to like it, but so what? I don't care, Alex. Now, here's an issue. What if you didn't get that y-intercept? Like, how are you going to find A? Maybe you could still figure out B. No, not even. Like, what if the table isn't even counting A1? You have got, it is quite the process. If you're watching this, I might have showed you that process in class, but I'll tell you for these, this is okay. Like, all honesty, the odds of you ever seeing a problem like this on an AZ merit it's one of the lower chance things to see. If you know it, great. If you don't know it, it's okay. It's something you should hear. All right, this is what we have heard since the class of the day that I'm making this video. So that was exponential growth and decay. Now, I'm going to write the generic formulas in here. Y equals A, 1 plus R to the T. That's the generic formula for growth. 1 minus R to the T. That's the decay. And then we also learned of this one. A equals P, 1 plus R over N to the NT. All right, I'm not filling in any of these values here, and obviously it's trying to suggest some sliders for all this stuff. It's not, this doesn't matter. I'm just saying these are the formulas I'm going to use when I'm creating formulas for some of these problems. So it says, to begin a bacteria study, a petri dish had 2,300 bacteria cells. Each hour since the cells has increased by 4.9%. Let T represent the number of hours since the study. Let Y be the bacteria cells, and write a function for that. So here's the deal. The bacteria is growing, and you have to look for the key words. It says increased. So increased tells me I need to use this first one. A plus times 1 plus R to the T. And all I need to fill in is A, the starting amount, and R, the rate at which it increases. So when I write it, I'm going to write Y equals 2,300, 1 plus. Now, be careful when you do the rate. My rate says 4.9%. You have to turn that into a decimal. So I'm going to turn it into 0.049 to the T. And that's kind of the answer. I'm going to fix that up a little bit here. I just want you to know, though, if you don't know how to turn it into a just pure decimal, percent literally means per each 100. So if you are told 4.9%, literally do 4.9 divided by 100, and it'll tell you the proper decimal. So if you have a calculator handy, that is definitely an option that you can pursue to get like the correct percentage as a decimal. All right, so there's my answer. When I go to write this in the actual form, I'm going to write 2,300. I'm not going to write 1 plus 0.49. I'm going to write 1.049 as if I added them together, because that is the proper thing to do, to the T, and that's it. Just putting it together. Now, I think it's going to get mad at me again for using parentheses, but I don't care. Alex, I do what I want. Here we go. It says use the no fractions. That's silly. I'd say use it. I like parentheses on these things. At the beginning of an environmental study, the forest covered 1,500 kilometers squared. Since then, the area has decreased by 2.7% per year. So be careful. You want to make sure you're paying attention to the keywords. Decreased means it's going down, which I'm going to use the second choice here, the decay formula. I'm going to plug in there. Also, I saw people getting a problem like this earlier today, and they were getting confused in putting kilometers squared like into the problem. Don't do that. The problem should just contain numbers aside from like the y and the t that you're using for like the variables that relate the time and the number of trees, well, tree area basically. So I'm going to write this. Y equals 1 minus, you have to use minus this time, 0.027. Again, if I didn't know how to do that, I would say 2.7 divided by 100. That's where I got that number from. Oh, I messed up. I forgot to put the starting amount in front. Dedoy. And then I'll raise that to the T. By the way, this is graphing this, but it doesn't really matter. Like, if I zoomed out, I would see the graph, but I'm not interested in seeing the graph. I am interested in fixing this, though. 1 minus 0.027 is not going to work. They're going to need me to simplify that. So maybe off to the side, let me write what that is. 973. I did see that earlier while I was typing stuff in without the front number. So when I write my final answer, I'm going to write y equals 1500 973 to the t. The key difference between growth and decay is when you have a decay, there should be a number less than 1 that's being raised to the power, or in my case is the parentheses. On the previous problem, the number in the parentheses was greater than 1, barely. Usually is barely, honestly. So less than 1 is decay, more than 1 is growth. So you can be sure you're doing decay correctly if it's less than 1. Okay, again, parentheses, blah, blah, blah. That's going to grind my gears until I just start doing it. All right, this is asking a little bit of a different question. This isn't asking us to make an equation. They gave me an equation, and they want to know some information about it. So it says, find the initial value of the car and the value after 12 years. For the initial value, you don't have to do anything. You just have to identify the initial value in the equation, which is always the thing out front. So the initial value is 29,900. I'm not putting a comma. Oh, it'll do it for me. I didn't even click that. It just does it for me. And then the value after 12 years, you will need to evaluate. Like, you don't need to do anything crazy. You just need to go to your calculator and type it in. Let's see. And there you go. You got an answer there. It says round to the nearest dollar. So I will round to 16,157 because the decimal after there tells me to round it up. Note that the value went down, right? The value of the car is going down, and you could tell it would because this number inside the parentheses, which I told you they use parentheses on there, even though they tell me not to put it like that, they're even doing it. Well, come on, Alex, Desmos, Alex, all the same thing. It's like when you don't know which kid to call which. You just say a kid's name and they're in trouble. This 0.95 is less than 1, so it decays, which explains why the value has decreased. Hey, it didn't get mad at me. I didn't have to use parentheses that time. All right, another one. This says current price and price 10 years from today. Please keep in mind this equation is referring to the current price. So, like, the current price isn't like something, you don't have to plug in anything but specific. That just really means, like, the initial price. Current price and initial price, and these problems are kind of interchangeable. So the current price is 800. This doesn't even have anything specific. It says of a price of a certain item. I wonder what's $800. Probably a pristine holograph first edition Charizard card from Pokemon. If I want to find the price of that Charizard card in 10 years, plug this in to the 10th because we want to know about 10 years. Ooh, to the nearest dollar, 1,024. Wow, that's such a great investment. I mean, I guess it's $200 free over 10 years. That's not terrible, except for you're not really beating inflation. Oh, this says the rate of inflation. Oh, so if it's $800, that will be how much it would cost with inflation in 10 years. That makes sense. Maybe it's not like a collectible item. Maybe it's just like what costs $800? The least expensive version of an iPhone. That's how much it'll be in 10 years. Okay, another problem. Keep it going. All right, a certain forest covers an area of 2,500. Suppose each year decreases by 4.5%. What will the thing be after 8 years? Now, we've had problems like this already. On the previous problem, it said write. Did it say write the equation? Yeah, it said write the equation. We didn't have to use the equation to evaluate, but now we need to evaluate, but we can't evaluate till we know what the equation is, so I got to make the equation. Now, the good news about this is when you make the equation here, I can type 2,500. That's the starting amount. Now, it says the area decreases, so I'll be doing 1 minus 0.425, because that's, wait a second, don't put 0.425. That'd be 42.5%. There we go. That's 4.25%. And again, if that was something you were iffy on, just divide it by 100 so you can see what to put on there. Okay, now here's the benefit of this one. On the previous problems, I had to fix the inside and find what the number was to write the full final equation. They're not asking me for the equation here. They just want to know what the answer is. So if I just go ahead and put to the 8th, they'll spit out the answer without me having to write a second line or anything. So do it. Round your answer to the nearest square kilometer. So 1766. The 2 tells me to round down. 1766. And it already has my units, kilometers squared, in there. Oh no, after 8 years they've lost 800 square kilometers. Not good. A can of soda is placed inside a cooler. As the soda cools, its temperature, in degrees Celsius, is given based on this exponential function. Ooh, the temperature decreases because this is decay. So it starts at 21 degrees Celsius. That's the first answer. What's the initial temperature? 21. That's what's out front. That's all you got to do. Is this growth or decay? This is why I was mentioning it earlier. This is less than 1 in here, so it's decay. And by what percent does the temperature change each minute? Now, in class, I really didn't describe how to find this value, and I feel like that was kind of a boo-boo because you will be asked to do this, here and there. The percentage is not 88. If you were to say 88 because that number in there is 88, that is wrong. The question is, how did it become 88? So, like on this previous problem, I did 1 minus that. That would have made a particular number inside there. What did you subtract from 1 to get 88? So if you want to know what you subtract from 1 to get 88, you literally subtract 0.88 from 1, and it tells you 0.12. Now make sure you don't put 0.12, you just put 12, because 0.12 is 12%. Okay? So this is missing 12%. That would have made 1 whole, and that's why we're choosing that one like that. I hope there's another problem like that. Next one, please, have the same kind of thing. Okay, good. Find the initial value of the car. So here's an equation showing a car. 26,000. Is this growth or decay? This time it's growth because 1.22 is over 1. It's gaining value. How much value? Well, that's what the third question says. What percent does it increase? Now, if I do it just like the last problem and I subtract... Oops, I put an extra decimal in there. I subtract, I get negative 22. I would not do it like that. I don't know how to describe it better than this. It's clearly more than 1. How much do you add to 1 to get 1.22? You add 0.22, right? So the percent of increase is 22. Use your logic. I feel like the increase one should be pretty logical. Decrease ones maybe not so much. And the only exception to the increase ones this is very tricky. If somebody showed you this formula, 3.2 to the t, and they were like, okay, how much percent did this increase by? The answer is 220%, because what do you add to 1 to get to 3.2? You add 2.2. But what is 2.2 as a percent? Well, 1 whole is 100%, so 2 wholes is 200%. So this is 220%. There's not like a way to write it as a percent. Sorry. Hey, look at that. If you want to find a percentage of a number, 2.2% of 100? Wow. I didn't even know that it could do that. That's interesting. Okay, well, I learned something new every day. All right, anyways, it's 22%. Next problem. All right, Lucy borrowed $8,000 at a rate of 14% compounded semi-annually, assuming she makes no payments. How much will she owe after 8 years? Yikes, Lucy. Never in your life, people, borrow something at 14% and don't make any payments for 8 years. You are going to be doomed. I hope this problem's answer will at least inform you of that. Like if you take a student loan out for college, I understand that you would do $8,000, but those, I don't know what the rates are now. When I went to college, it was like 6 or 7%, and those were the bad ones. 14% is a death sentence in terms of money. Whatever, let's do the problem. So $8,000, the initial amount, it's adding 14%. Like she's got to pay back $8,000 plus additional money. So this is actually exponential growth. The amount of money she needs to pay is growing. So I'm going to put 1.14 because it would be like having 1 and then also having like an additional 14. I could have put 1 plus 0.14, I guess. Not a big deal. 1 second. Sorry, I had to do a little cough there. All right, and then I'm going to raise this to a certain power, and it says after 8 years. There you go, 8 years. So there you go. I didn't need to make any, I didn't need to put y equals or anything. I mean, I could make the formula like y equals blah, 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 this to the t, but they don't want the equation. They just want what the price you'll pay in 8 years. And so I went right for it. It says do not round any intermediate computations, but do round your answer to the nearest cent. Cent, not dollar. So 69 cents is where this is cut off. So 22,82069. Now let's just stop for a second and take a look at that problem. This is real life right here, people. If you borrow $8,000 and they tell you you get 14% interest charge, and you don't pay any of it back for 8 years, you will have to pay back $22,000 instead of 8. So don't do that to yourself ever. And I can tell you a very easy place where 14% is a very minimum amount you'd have to pay. That's a credit card. Very, very low credit cards would charge 14%. And look how bad it is. You can't not pay your credit cards for 8 years. You know what I mean? And that's why I also give you this advice, adult you. Do not neglect to pay your credit card, and do not make a minimum payment, because you'll just basically be making a dent in the interest charges you get. Always pay as much as you can. If you borrow $8,000, you better pay that guy back as fast as possible, or you're in trouble. What? What did I do? Oh, I made a huge mistake. Oh, I'm so dumb. All right. I can't read. This is what you get for not reading. You know what this means? The answer is going to be even worse. It says it was compounded semi-annually. I didn't read compounded semi-annually. I just put it right into exponential growth. But this isn't just exponential growth. This is compounded exponential growth. So I should have put it into this formula. So let me put it into this formula. I'll use the 1 plus on this one to be fair. 0.14 over, so I'm doing 1 plus the rate, 0.14, over how many times per year? Semi-annually means twice. So I'll make this 2. Now you notice it looks like it's less, but it's really not going to be less because I haven't added this in yet. You do nt, which means whatever the base number you put here, times that. So 2 times 8. There we go. That's correct now. So the starting amount, P, times 1 plus the 0.14 over 2 to the 2 times 8. So this n represents how many times per year it compounds, which means that's how many times per year they add on extra charges. And you'll notice that raised the value. At least we got to see what the value would be without compounding. Compounding makes it worse. Now it's 23, 6, 17, 31. Yikes. 23, 6, 17, 31. Look at that. So much, well, it's not tons worse, but it's definitely a little worse. So that's even a worse deal. Okay, now let's make sure this is right. Oh my gosh, I feel bad. Oh my gosh, when a number is large, use a comma for every thousandths place. Fine, okay, whatever. We all know it's 23,000. Okay, sorry I missed that the first time. I can't read, apparently. Compounded semi-annually. I forgot. Even I knew the homework had compound interest on the last few questions. All right, we'll do better on the next one. Suppose $2,000 is invested. So we're going to start with 2,000. I'm plugging in this because I know it's going to be compounded. It says compounded quarterly. So 2,000 times 1 plus 3.2%. So 0.032. That's what 3.2% is. Compounded quarterly. So that means 4 times per year. So over 4. And if it's being compounded 4 times a year in the exponent, I have to put 4 times. Now be very careful. If you look at what Desmos just did, I put times and it put it down in the base, not in the exponent. So you might need to put a little parenthesis in the exponent to make it happen. 7. Okay, so let's review. $2,000 to start. Times 1 plus 0.032 over 4 because it's compounded quarterly. And I raise it to the 4 times 7 because it's compounded quarterly for 7 years. And this is what I get, 249991. Round to the nearest cent. All right, you got it. 249991. Will I get mad for not using a comma? You know what? YOLO, I'm not doing a comma. It'll give me the points anyways. Now, that's not a ton, right? Look at that. You put 2,000 in. You wait 7 years. You only get about 2,500 out. You only get $500. I mean, but the real deal is the percentage. 3.2% is not a lot. Let me just, for the sake of showing you math, say the rate was 6%, double the percentage, right? You get a lot more money, right? Instead of making $500, you make about $1,100. It makes a big difference, right? So higher percent is always good. I was just using that as an example. Hope our answer's right. I don't have to go back. Okay, cool. One more. The Johnsons are saving up to go on a vacation in 2 years. They invest $2,900 into an account with an annual interest rate of 1.23 compounded monthly. Ooh, 1.23 is terrible, but that's kind of what banks will tend to give you if you put your money in a bank account that offers that kind of stuff. So that's 2,900. 1 plus 0.0123. That's what the 1.23 is. Compounded monthly over 12. We are going to raise this to the 12 times something. Answer the questions below. Do not round anything. Okay. Assuming no withdrawals are made, how much money will be in the account after 2 years? So when I do this exponent, I'm not going to put 12. I'm going to put 12 times 2 because that's what 2 years looks like. So I'm going to round to the nearest cent again. It looks like 1972.19 because the 8 turns into 9 because of 7. How much interest is earned on their investment after 2 years? Now, this is not the same answer as what I just put. This is how much is in their account. But how much money did they get is the question. So what I need to do is I need to take what I just got. I can use my rounded answer. It'll be okay. And I need to subtract from it how much they put in. They put $2,900. They made $72.19. That's a terrible amount, but I think it's the right amount. There you go. So on this particular question, and this is a good question in real life, how much is the difference? On that previous problem I was doing, that was an important question to me too. For example, if let me just give you a scenario here. This isn't even a problem I'm doing, but let's say you put $15,000 in an account and it gains 15% and it's compounded twice annually. So I'm going to raise that to the 2 times, and you do this for 10 years. That's a lot of money right there. 15% is incredible, right? And compounded twice annually only makes it better. But did you really get $63,000? Not really. You got $63,717 minus however much you put in. So you really made $48,000. That's amazing. So that's the trick right there. You got to make sure you find the difference, okay? Also, if this is possible in real life, please do it. I mean, $15,000 is a lot to put down, but it turns into in 10 years' time, you get quadruple your money. Just imagine what happens if you were to put it in an account and wait for 30 years and see if you could retire. 30 years later, $1.1 million. Okay? So my advice to you, I mean, I don't think you're going to easily find $15,000 lying around to invest right now at 15%, mind you. 15% is a ton. But if you can invest it and do it now, that 30 years will come faster, and you can maybe sitting on this kind of chunk of change even faster. You know what I mean? Even if you put $5,000 in, you still get $300,000. Can't get 15%? Okay, I'm sorry. Maybe 7.5% if you're lucky. Okay, not bad. $5,000 turns into $45,000. And here's a pro tip in life. If you put $5,000 in, that's not all you're ever going to put in. You'll keep putting more in. You'll put $5,000 here, don't even put $5,000 here, put $500 here, then $500 there. Then each year put $500. And then it'll slowly accumulate. It'll really build up. I mean, this is the math right here. This is the math that makes you happy at the end of the road. So make sure you're doing it, all right? All right, I'm going to submit assignment. That was my lecture. Let's go to the report real quick. Let's review. So the first 2 problems, I was given a table and I needed to find a formula. I simply found the y-intercept and the pattern and made that A and B. A was the y-intercept. B was the pattern that y was following. 4 through 9 was a mix of writing exponential growth into k functions Let me go to 4 here. The first one was a growth. Then I wrote a decay. And then we then we had a formula that we found the initial value. Then we plug stuff in. So you can do a lot of plugging in here. Plugging more stuff in. Oh man, in hindsight, these were so easy. Plug stuff. This one was make the formula and plug stuff in, which we totally did. Had a few of those. This one, they gave me a formula. I had to decide if it was growth or decay and by what percent. That was 8, 9. Then 10, 11, 12, we did compound interest, and I whiffed big on 10, but we recovered because I learned how to read. And then on 12, they had a compound interest problem just like the others, but also added in how much do they actually make? Oh, this is why you don't go 1%, man. 1% for 2 years, you get $70. Meh, what are you gonna do? You're gonna eat some Red Lobster is what you're gonna do. And that is some advice right there. All right, that's the end of the video. And if you watch this whole thing, good job, man. This is 30 minutes long. You're a genius now. That's all I got to say about that, and I'm out. Bye.